All right, so I'm happy to introduce Daniel Usma-Gomez, a PhD student at the University of Lorraine, and in addition to his work on Thomas Aquinas that he'll present to you right now, I want to credit him for being really the inspiration for this conference, because he reached out to me and suggested doing some collaborations, and then became quickly apparent that many of you were interested from all over the world. And so I reached out to James Franklin and Nusset and others, and then quickly we ended up with a kind of worldwide roster, and it became clear that it made more sense to just do the whole thing on Zoom, which has allowed a wonderful array of participants. So thank you everyone for joining, and please go ahead, Daniel.
Okay, thank you too for the invitation. So today I'm going to present some insights, some points which I'm working at this moment, and it's about recent reading of Svoboda and Susdik paper so I will start again. So in a 2020 paper, Svoboda and Susdik suggest that Aquinas' philosophy of mathematics would be twofold, and that both parts would be contradictory and irreconcilable. And we could find in Aquinas a realist account in Boëtius' commentary on Boëtius' Question 5, Article 3. And this philosophy of mathematics would state that the objects of mathematics are real features of things, and as such, they are grasped by formal abstraction from which we obtain quantified substances. And in addition to this, there would be another philosophy of mathematics in Aquinas' texts, which would be non-realist, and it could be found especially in a later inserted text to his commentary on Peter Lombard's sentences, and somehow in the Question 5 of his commentary on Boëtius and other passages. And here Aquinas would suggest that the objects of mathematics would be free creations of mathematicians' intellect. And the reason is that mathematical objects have no proper real counterpart in reality, given the fact that their close foundation is the intellect and not reality. So I wonder which are the reasons to ascribe such a double view to Aquinas. And I see that Svoboda and Susdik give three arguments to support this reading. And I will briefly expose the core of each argument, and in order to suggest why I think it could somehow be possible to interpret Aquinas in a fictional way without claiming that such reading is correct. And I will finish with some remarks on the relevance of Aquinas' philosophy of mathematics for contemporary philosophy of mathematics, remarks which are somehow the starting points of my general work for the 3 years to come. So the first argument is that Aquinas' realist philosophy of mathematics is closely linked to the status of mathematics as one of the three theoretical sciences. And in his commentary on Boëtius' Question 5, Article 1, Aquinas holds that the end of the speculative intellect is the truth that it contemplates, and that the subject matter of speculative sciences must be things that cannot be made or done by us. Then if it is the case that mathematics is a speculative science, it must be concerned both by the truth and by something that cannot be made by us. But Svoboda and Susdik point out that these statements are in serious conflict with the claim in the answer to the objection 3 in the same article that mathematics are concerned with the quadrivium. And as concerned, or even as a part of the quadrivium, mathematics would be an ars rather than a scientia. And following Thomas, the disciplines of the quadrivium are called ars because they involve not only knowledge, but also work that is directly a product of reason itself. So as an art, mathematics would produce its subjects, which is in contradiction with the statement that as a speculative science, mathematics cannot produce its subject matter. So I wonder if this is not quite a quick conclusion, we should consider the fact that in Middle Ages, various divisions of sciences and various criteria of to divide knowledge were generally accepted by philosophers, something we could see in the works of Johann Cadden. And indeed, we seem to find, for instance, institutional divisions on one hand and formal divisions on the other. And this seems to be supported by Aquinas himself in his introductory remark to the aforementioned passage. Thomas said that the 7 liberal arts do not adequately divide theoretical philosophy. So it is true that Aquinas accepts the division of sciences in liberal arts, but he also accepts the threefold division of theoretical sciences. And if in that way, I suggest describing a distinction between scientific knowledge from scientific activity, and in regard to mathematics, mathematical knowledge from mathematical activity, rather than ascribing Aquinas a contradiction. And I will keep this point for later. The second argument of Svoboda and Susdik concerns the operation by which we grasp the objects of mathematics, the operation of formal abstraction. And Svoboda and Susdik point out that following Thomas' descriptions of mathematical knowledge in his commentary on Boëtius, Question 5, Article 3, one should be led to see the objects of mathematics as universals, as well as those of physics, which we also obtain by abstraction. In addition, they remain that the subject matter of speculative sciences must be universal, necessary, and immaterial. But, they continue, this leaves and explains the individuality and the contingency of some mathematical objects, as this line, this circle, this square, this number, etc. And Aquinas himself does not go further on this point elsewhere. And in addition to this, the link that Aquinas establishes between mathematics and imagination are in conflict with Aquinas' account of formal abstraction as the way the mathematician grasps its objects. We find some texts, for example, this 3, where Aquinas says that the objects of mathematics could be in the imagination, and that mathematical judgment could have its terminus in imagination. So, putting formal abstraction at the same level as total abstraction, that is the abstraction of physics, seems to Svoboda and Susdik unbearable for logic reasons. For the latter, we obtain universals, but not with the former. And clearly, we seem to face a puzzle, be faced to a puzzle. But again, I wonder if this conclusion would not be prompt. We should consider some passages where Aquinas speaks of imagination and its objects in an analogous way as an intellect in order to account for the intelligibility of some mathematical objects despite their individuality. And what Aquinas could be trying to say with this that's a question. But this shows us that Aquinas knows that they are individual and universal objects of mathematics. And whether or not this is contradictory is a quick question for me, for we could also consider that Aquinas is perhaps making correspond both individual and universal objects of mathematics to both powers of the rational soul as imagination and intellect. And if this is correct, Aquinas could have been considering another distinction between the proper objects of mathematics and from imaginary objects of mathematics, and I will keep aside this for later too. So the third argument of Svoboda and Susdik is that the objects of mathematics, as we find them in the thought of the mathematician, have no real counterpart in reality. And in other words, we cannot find in reality a line, a circle, or any mathematical object being exactly as it is in the mathematician's thought. And Svoboda and Susdik conclude that in virtue of the lack of real counterpart, the objects of mathematics cannot be, say, abstracted. Otherwise, mathematics would be false because abstracted objects that do not resemble real things are false objects. So since Aquinas sometimes ascribe features to mathematics, to mathematical objects whose real counterparts do not have, the authors conclude that the mathematical object does not seem to be grasped by formal abstraction because abstraction does not lie. And we have two groups of texts being quoted by Svoboda and Susdik to support the view. And Svoboda and Susdik says that if mathematical objects do not have the same properties as their real counterparts, they are not abstracted. And they ask, what kind of existence do they have then? So the situation is the following. In his commentary on Boëtius de Trinitate, Aquinas would be claiming that abstracted mathematical objects have real counterparts, and this would be the realist philosophy of mathematics. But in the other text, Aquinas would be claiming that the objects of mathematics have no real counterpart, and this would be the non-realist philosophy of mathematics. And one could ask if this allows us to immediately conclude to a twofold account of mathematics whose parts are contradictory. And Svoboda and Susdik's solution is the claim that the objects of mathematics depends on human mathematical reasoning. And they account for this from Aquinas' later inserted text to his commentary on Peter Lombard's sentences considered years ago by Armand Maurer. And in this text, Thomas distinguishes three kinds of notions. Notions whose immediate foundation is in reality, as universals and notions of physics, notions whose immediate foundation is in the intellect and whose remote foundation is in reality, as logical and mathematical notions, and three, notions that have neither immediate nor remote foundation in reality or in the intellect, as chimeras and other fancy notions. And given that the second kind of notions have their immediate foundation in the intellect and only a remote foundation in reality, Svoboda and Susdik will hold that mathematics would investigate not a really existing order, but an order created by the human intellect when it cognizes reality. And given that Aquinas characterizes the second kind of notions as intentions, which means that they have what Yves Simon called a condition of reason, to say that mathematical objects are intentions would be equivalent to say that human mind plays the main role in grasping mathematical objects. And combined with references to imagination, this leads Svoboda and Susdik to the claim that mathematical objects are free creations of mathematical reasoning. Then both numbers and geometrical objects are thus understood as sui generis fictions, as constructs of our minds. And it seems that, according to Aquinas, even the whole numbers are invented by human beings. And both take the constructions of numbers as an example of this. Aquinas seems to insist that absolute numbers are deliberately created by human beings in counting by adding a unity to the preceding number. And numbers of this sort are not present in counted objects, which are particular multitudes. And numbers obtained in this way and not in particular multitudes, then these absolute numbers are sui generis fiction because they are mainly constructed by the intellect. But again, I wonder if this conclusion would not be also too quick. For one should ask if a constructive act of the intellect necessarily entails that numbers and generally mathematical objects are sui generis fictions. It is, I agree, it may be difficult to see how numbers as 1 million or enormous quantities, or even numbers as imaginary numbers as e or rational numbers as pi could be abstracted. And I know mathematics has certainly a constructive part which cannot be neglected, but whether this constructive activity must be interpreted as fictional is hard to decide from Aquinas' textual evidence only. For in Aquinas' account, there is a neglected notion which clashes with a fictionalist reading of Aquinas' account of mathematics. And this notion is the notion of intentio. And in his inserted text to his commentary on the sentences, Aquinas refers to notions having an immediate foundation in intellect as intentiones. So the second kind of notions are intentiones. And intentio in Aquinas seems to have a double status. On the one hand, it signifies a way of knowing consisting in receiving a form that in physical things has an esse naturale, and that in intellect has an esse intentionale or esse in intellectus. And on the other hand, it also refers to a mode of existence when he speaks about intentions. It's an esse intentionale. Yes, both the way of knowing and the intellectual mode of existence depend on an intellect in act, which implies that there is no intentionality and then no intentions without a knower. But we could still notice that in Aquinas' view, something of an ontological dignity is allotted to these objects, which is not the case for chimeras, which are the notions of the third kind. And at least intentiones would be anything but not fictions, in my own, which something we could find in readings of Gage, Haldane, Kenny, Liska, etc. So, moreover, I think we could find helpful hints in Aquinas' inserted text. Aquinas' threefold distinction seems to precisely indicate that despite the immediate foundation in intellect, mathematical notions are not fictional. And the difference is that intentions are still true in spite of the only remote foundation in reality, unlike chimeras. And since modern fictionalism seems to be inconsistent with the correspondence truth model, which is Aquinas' model of truth, we might question the rightness of a fictional reading of Aquinas. And if I am correct, I will keep aside also the theme of intentionality for later. So now I will be looking into the consistency of Svoboda and Sosdik's reading, which seems to me to be supported by some contemporary discussions in philosophy of mathematics, despite its conflicting points with general metaphysics of Aquinas. I think they are right when they insist on the constructive feature of Aquinas' second philosophy of mathematics as being more accurate to contemporary questions in philosophy of mathematics. And an example of this could be the well-known Benacerraf's dilemma. Fictionalism is one of the most popular anti-realist strategies to overcome Benacerraf's challenge. And this strategy could take various forms, going from denying the need for mathematics to mathematics to be true or false, to introducing a multi-form of semantics accounting for fictional truth, or reducing mathematical propositions to non-mathematical propositions, all inspired whether by Weihinger or Peirce or Field's fictionalism. And these views may share some interesting elements. One of them is the role of imagination. Imagination plays an important role in the construction of mathematical propositions and of mathematical objects to model the world. The second is the mathematics heuristic function, pragmatic or instrumental function. And mathematics do not describe the world, but helps physical theories to describe the world, and which is sometimes expressed as an argument of methodological indispensability. And the third is the abstractness of the objects of mathematics as a cognitive feature of mathematical objects and not a mode of existence at all. And it is at best a kind of representation or idealization with no need of real counterpart. And when we look closely, these features which could be read in such a way that they would be not so stranger to some of the aforementioned Aquinas philosophy of mathematics. On one hand, we have the imagination as terminus of mathematical judgments of mathematical objects. Second, we have mathematics as an instrument in hypothetical physical proofs and necessary physical proofs, in some texts as Summa Theologica and some texts in the posterior analytics. And the status of some mathematical disciplines as scientia media, which is exposed by the works of William Wallace. And finally, the intentionality of the objects of mathematics having a conditional reason, and the fact that the abstractness of abstracted mathematical objects is formally caused by the operation of the intellect, and it is not a separate mode of existence. So we could find something as a family resemblance. And however, one ought to wonder if a family resemblance suffices to commit Aquinas with a fictional account of mathematics. And I think whether or not it is the case depends on how we deal with his account of truth and with the intentionality of mathematical notions. And my questions at this point are, would Aquinas have accepted the notion of fictional truth or the refusal of truth in mathematics? Or would he have accepted a fictional portrayal of intentionality of mathematics? And I think the question is not settled, but that's why I'm working on this also. So to finish, I'm not going to discuss what I think is the relevance of Svoboda and Susdik's reading of Thomas for contemporary philosophy of mathematics. And as I have suggested earlier, the merit lays in their emphasis on the constructive feature of Aquinas' account of mathematics, a more attractive feature to contemporary philosophies of mathematics and the mode of existence of mathematical objects. And by doing that, Svoboda and Susdik seems to me enable Aquinas and medieval philosophy to communicate with contemporary philosophies of mathematical, and that's why I find the reading very interesting. And as we saw, since we somehow find the family resemblance between some features of fictional accounts of mathematics and Aquinas' philosophy of mathematics, and given Thomas' refusal of Platonism about mathematics and some other elements linked with his academic context, it seems to me that Aquinas' philosophy of mathematics appears to be close to fictionalism. But the question is, does this enable us to consider Aquinas' conceptual frame for philosophy of mathematics as a candidate to build a strategy, a fictionalist strategy, to overcome, for example, problems as Benacerraf's dilemma? That's a question. And we could see that in his commentary on Boëtius, the question commanding the third article of the question 5 is, does mathematics treat without motion and matter of what exists in matter? And in Maillard, this question concerned both, one, the subject matter of mathematics, which is linked to the Plato's problem, and two, the modality of our mathematical knowledge, which linked to the problem of access. And if Plato's problem and the access problem are really linked with Benacerraf's dilemma, and if Aquinas provides an answer to these questions, I wonder if this does suggest that 11th and 13th century philosophers were concerned by at least the germ of our contemporary issues about mathematics, and if that the Thomistic answer to Benacerraf's dilemma could be built. And also to go further with the dialogue between medieval and contemporary discussions about mathematics, I would like to consider William Wallace's remarks in his 1961 Aquinas, Galileo, and Einstein. In discussing Aquinas' views on mathematical physics, Wallace suggests that Aquinas' views about mathematics could have been influenced by both Oxford's and Alfred the Great's attitude towards mathematics. On the one hand, Grosseteste and Bacon's remark of the indispensability of mathematics to physics, and on the other hand, Albert's emphasis on Aristotle's kind-crossing prohibition to insist that the subject matter of mathematics is radically different from physics, and somehow that mathematics would be somehow dispensable. These 2 points would have led Aquinas to an intermediate insight with respect to the applicability of mathematics. And mathematics may have an important role in hypothetical and necessary proof, even if the success of a proof doesn't depend on its being mathematical. And this seems to suggest, at least to me, that something of primitive arguments for the indispensability or the dispensability of mathematics were hardly discussed in Aquinas' time, and those that is maybe not so stranger to our issues. And if I am correct in this, one of my inquiries would be concerned with what medieval and 20th century mathematical contexts could have in common, if any. And one might ask if there could be some threads common to both medieval and contemporary context. Yet, in spite of their merit, Svoboda and Susdik's fictionalist reading of Aquinas' philosophy of mathematics seems to me quite contentious, for it goes against some important claims of Aquinas' account of truth and metaphysics. And I wonder at this point and to finish, if another reading could be possible. And I consider the 3 points I have isolated earlier to sketch some remarks I have from some discussion with an American friend, Timothy Kearns. We have exchanged some messages by email, and it will be very helpful to me. So these 3 points is Aquinas' distinction between mathematical knowledge and mathematical activity. 2, Aquinas' somehow implicit distinction between objects of mathematical knowledge and objects of mathematical activity, combined with both accounts of an abstraction and own imagination. And the 3rd is the theme of intentionality of mathematics. And at this point, we could follow Jean Rioux in his numerical foundations, mathematics as episteme, by seeing the constructive activity of mathematics as an activity of construction from a narrow domain of abstracted objects and some general principles as basic mathematical operations. In Rioux' words, this means that to construct numbers or geometrical figures, we proceed from general abstracted objects as arithmetical unity and continuous quantity to numbers or to figures, respectively. And nothing seems to prevent us to see this construction as having the terminus in imagination, which would be the locus of constructed numbers and constructed geometrical figures, maybe. So the criterion of cognitive dependence that we find in Aquinas' account of abstraction, that is to depend on something to be understood, could be extended also to objects of this construction. So even numbers as, for example, imaginary numbers or objects of non-Euclidean geometries could be seen as derived or constructed from abstracted objects on which they depend cognitively, maybe. And despite the lack of real counterparts, it remains that they are true in Aquinas' view. Then in some sense, constructed objects would be true of abstracted objects or notions, and in some sense, imaginary objects of mathematics would be true of abstracted objects of mathematics, which would in turn be true of real objects, maybe. And if this is correct, we easily could distinguish mathematical activity whose objects would be mainly imaginary from mathematical knowledge, which is the perfection of the intellect, to which we come by abstraction. I don't properly know this constructed triangle or number, but the essence of triangle or the essence of absolute numbers. And an example of this could be found, historical example of this could be found in some works of Jens Heurup about Jordanus de Nemours, where he says that in some translations of Al-Farabi's works distinguished mathematical activity or arithmetical practice and arithmetical theory, and that arithmetical theory deals with objects we understand as abstracted, and practical mathematics and practical arithmetic deal with constructed objects. And I don't know what to say about that, but it's to me an important hint. And finally, regarding to the intentionality, its double status would be of interest with respect to Benacerraf's dilemma. And if an intentional reception for form, which is an epistemic feature, involves both things known and now's mode of existence, which is an ontological feature, it would follow that to know what an object of mathematics is, we ought to describe the way in which we know mathematics. Both why mathematics is truth and how we reach mathematical knowledge are no more two mutually exclusive questions, but two sides of the same question. If this is correct, then Benacerraf's dilemma is no more a dilemma, but a single question requiring both an epistemic and an ontological answer to be treated completely. And this seems possible in Aquinas' point of view, for since the abstractness of mathematical objects consists no more in a causal inertia, but on the contrary, is obtained by a causal operation of abstraction and etc. It clashes no more with the causal theory of knowledge. So that's why Aquinas' philosophy of mathematics appeared to me to be something as a realist constructivism. That means that is constructed mathematical objects conserve an ontological dignity. That is, they are real in virtue of the reality of both knowers, real beings really capable of knowledge, and known things, real things, really knowable. That's all. Thank you so much.
Thank you so much, Daniel. That was really great. All right. Yeah, so we have perfectly 15 minutes for questions. So who's up first? All right, well, I'll lead it off myself, and you can all think of your questions. So Daniel, I guess I'm a bit curious about the original setup, which I know you transcend in the end, but the original setup between kind of Aquinas, who, you know, I guess came out of the Savoda article, right? Which the Aquinas from the commentary on Boethius, who wants to kind of treat mathematicals as grounded in reality, and then the other passage in which maybe he wants to treat mathematicals as less grounded in reality. And if I recall, on the kind of right-hand column there, the ones where the texts where they were not so grounded in reality, I mean, a lot of them were from the Sentences commentary, which of course is very early and often less precise. One that would have been from a similar period, from a late period that we should take seriously, would have been the Metaphysics 11 text. But there, I guess I don't really see what was even supposed to indicate a kind of fictionalist story, right? So he says, first of all, he's describing someone else's position. He says, then he argues on the other, so Aristotle argues on the other side of the question. If the objects of mathematics are not separate, it's difficult to indicate the things with which mathematical sciences deal. They do not seem to deal with sensible things as such, because no lines and circles such as the mathematical sciences investigate are found in sensible things. So that's maybe a bit of a pushback on Franklin's view of Aristotelianism. But it seems necessary to hold down that there are certain separate lines and circles. And then Aquinas says, now the truth of the matter is that the objects of mathematics are not separate from sensible things in being, but only in their intelligible structure, as been shown above in Book 6. So he takes this to be a kind of dialectical argument from Aristotle that he's expositing, and that he's coming down from in the middle of it. So I guess that obviously agrees with where you end up in your talk, but I guess I don't even understand how it's supposed to be a dialectic from the start, as if there are some passages on one side and some on the other side. It seems like this passage that was taken to be one of the fictionalist passages just straightforwardly supports the view that you give at the end of the talk.
Mm-hmm. Yes, thank you for your remark. The view that Aquinas could be fictionalist is the bold enthusiastic view, and what I'm trying to do with that today, was trying to say to do is to oppose myself to the lecture, because I do not see what could suggest that Thomas Aquinas is fictionalist. What I see is that could be something as a family resemblance in between some features of Aquinas' philosophy, or of Aquinas' remarks of about mathematics, and some features of modern fictionalism. But I think this is a kind of habitus, kind of habitude of some philosophers to link, for example, Peirce's features of epistemology with another features of Aquinas, without being intimately linked. But I agree in you, if I understand you correctly, when saying that it seems to me that in Aquinas there is no elements to suggest that he could be a fictionalist. And that's why today, the question was, is Thomas Aquinas fictionalist, which would be especially a question to Svoboda and Susdik, which suggests this in his paper, in their paper. Sorry, I don't know if I answered you.
No, great, thank you.
Yeah.
All right, Jim.
Can you comment on why the imagination is useful in mathematics? It doesn't seem to be much use in, say, metaphysics, talking about universals and particulars or something, but it's very useful in mathematics to, for example, imagine intersecting circles or to imagine the number line. What is it about mathematics that means the imagination can help you get to truths about it?
It's a good question. It's a good question. So I do not have the answer right now. But what I could say, if in doing this this comparison between intellect's formal abstraction and the activity of imagination, is especially suggestions, hints of reflection, because some remarks in Aquinas' philosophy of mathematics about imagination speaks on imagination in an analogous way to intellect's formal abstraction. And the question is very, very complicated, but I think it depends on how we understand the general term of abstraction for Aquinas. And I think somehow this term of abstraction is a very general term to describe the way in which we grasp mathematical objects, universal mathematical objects, or individual mathematical objects. And I think it's a very general term to describe that, or to say that the imagination functions as intellect, and its operation is somehow an operation of abstraction, because he puts aside features which are material, some things that are material, but it conserves somehow mathematical features of mathematical, individual mathematical objects are parts of the, as for example, two semicircle, which are parts of an individual mathematical objects, but not part of the essence of mathematical conclusion. So if this is true, the question, Jade, is if Aquinas would say that these objects of imagination are true or not. But I don't know, this just a hint I'm exploring, actually. I don't know if I have the answer to the question, to your question.
Okay, Afra.
I'm sorry, I can't speak, but I wrote my question in my chat.
Okay, I read it. Okay, so Aquinas' text, in which he speaks about the operation of counting as a constructive operation, is very, very vague. So it doesn't say if this its operation could be described in the language of iteration and other things. But I think Svoboda and Susdik have great reflections on this in their paper Aquinas on number, or something like that. I don't know if Aquinas could be described this in a language of iteration. And would abstraction, this construction of the notion of intention, help with that? I don't know. It's a good question. I will reflect. I will reflect on it and work on it to the years to come.
All right, Eduardo.
Yes, thank you. actually following up on Ryan's commentary, it left me wondering whether you're considering the approach that an approach that is very common in Thomistic circles in the United States, especially followers of Whipple and others, of doing pretty much what Werner Jaeger did with Aristotle, trying to figure out the evolution of his thought. So what they tend to do is they place chronologically the texts, and then they think that if there's anything that looks like a contradiction, then maybe there was an evolution in his thought. And there are, people argue that in certain subjects he changed his mind more than once. I totally disagree with that, but I was wondering whether you were taking this approach into consideration, some kind of heterogeneous rather than homogeneous evolution of his thought.
Yes. Thank you so much. The question is somehow treated by Svoboda and Sustik, who precisely indicate that the second text, or the second philosophy of Aquinas, philosophy of mathematics of Aquinas, is a product of his mature thinking, and yes, the same. But what I try to do with this is to state that even if even if there is maybe an evolution of Aquinas' thoughts, there is no contradiction. There's no contradiction, and that the second view of Aquinas about mathematics fits perfectly with his first views about mathematics. And that's why the notion of intention is important to me, because some discussions in the United States about the notion of intention points out that the notion of intention has an evolution from an Avicennian conception of intention for a young Aquinas, and a non-Avicennian conception of intention for an Aquinas who is more mature or something like that. Maybe, I don't know, but in the case of philosophy of mathematics, I don't know, there is a contradiction by saying that mathematics would abstracted objects, etc., etc., and on the other hand, that notions of mathematics are as intentions or whatever. Because I think that in the second philosophy of mathematics, Aquinas is more speaking of mathematical activity and less of mathematical general knowledge, which is the subject of the question 5 in his commentary on Boëtius. He's just giving a general description of philosophy, and that's why he precisely indicates that the quadrivium and sciences that are mathematical disciplines and scientia media, etc., doesn't properly divide the philosophical division of knowledge. So, but the remark is very, very helpful. Thank you.
Thank you very much. By the way, I have I'll post on the chat a recommendation I wanted to give you of a book that I think might interest you in precisely this latter point that you're making. Thank you.
Okay, thank you so much.
All right, let's thank Daniel.
Thank you too.